Okay, welcome back, Hononegah. Honors Algebra 2, Section 6.4, Transformations of Exponential and Logarithmic Functions. Just like any other graphs that we have done throughout this year, we've always talked about how we want to do any transformation. So the things that we have done in previous chapters still apply with exponential and logarithmic functions. So again, if I want to do a horizontal translation or a vertical translation, a reflection, horizontal stretches and shrinks, and vertical stretches and shrinks. So again, we've gone over this multiple times, but there's still people that struggle on it. Um, what you do to the entire function is if you have something go up or down, you're going to add to the function. Or if you're going to flip something over the x-axis, you're going to multiply everything in the function by a negative. Or if you are going to do a vertical stretch or shrink, you're going to multiply the entire function by a number. And then what happens if you want to replace x? So if I want to go left or right, I'm going to replace x. If I want to do a reflection on the y-axis, so this one is the y-axis, okay, this one is the x-axis. And if I want to do a horizontal stretch or shrink, and remember when you're replacing x, it's always the reciprocal of. So all the examples over there on the right-hand side deal with the fact that you're either going to replace x or you're going to do it to the entire function. So here we go. Describe the transformation. Y is equal to 1/3 raised to the x, represented by g of x is equal to 1/3 raised to the x minus 5. Then graph each function. So what did they do? They subtracted 5 to the n. So that is a translation down 5. And so now if I wanted to graph the original graph, I'd do an XY chart and I would put numbers in for x. I'd always put numbers in for the exponent. Okay, so then I have a situation that if I put, let's say, 1 in for x, I get a third. If I put 0 in for x, I get 1. If I put -1, I get 3. And so, or -2 would be 9. So here's -2, 9, -1, 3, 0, 1. And so this is exponential decay from section 6.1. Now, your choice here. You can do it separately. I'm going to use a different color here. Y is equal to 1/3 raised to the x minus 5. You could do a, because you know the transformation, you literally can do everything to the right 5, or excuse me, down 5, because that's what the translation does. So I know that if I tried 1 and I went down 5, it'd be -4 and 2/3. Or 0, it would be -4. Or -1, it would be -2. So again, these are all situations you don't have to do an XY chart for the other one. You can, and it would make sense to do it. But all that's happening on this is all of these points are going down 5. And so this is a situation that, and again, be careful here, there is an asymptote. And the asymptote is actually at -5. So instead of the asymptote being at 0, the asymptote is at -5. Describe the transformation. F of x is equal to e, I'm just going to write them down. F of x is equal to e to the x, and f of x is equal to e to the x plus 2 minus 1. So what did they do here? Well, they replaced x with x plus 2, so that is a translation to the left 2. And then a -1 would be a translation again down 1. And so let's graph. And again, this one's going to require a little bit of an XY chart. You're probably going to want a graphing calculator for sure, but I'm going to plug in some numbers for x. So I've got e to the first, and e to the 0, and e to the -1st. So let's go to a graphing calculator. Y equals. So I'm going to go y equals e. Remember, e is located on the left-hand side, so e raised to the x power. And we did this in section 6.1. And so it's exponential growth. And so now I'm going to do an XY chart and get some numbers here. And so now my table set, I don't want that to go by 0.2s. Let's try that again. Let's try this one more time. Sorry about that. So now 1 would be 2.701.337. So 2.7 and 0.37. 1, 2.7, 1. And so again, this is exponential growth. Now, again, I could type this new one in to the graphing calculator, and I can get points just like I did before. But I also could just go to the left 2 from each of these points and down 1 from each of these points. So on the graph, if I went left 2 and down 1, if I went left 2 and down 1, okay, left 2 and down 1. So again, this is just the same graph as long as you go to the left 2 and down 1. But you can also use a graphing calculator. So don't if it's a y equals question and you want to type this in. So if I went back to my graphing calculator here and I went and typed in e raised to the x plus 2, and then I got to arrow down minus 1, I get the same graph, just move to the left and down 2. Next one. All they want me to do is describe. At least I don't have to graph anymore. Now, this one's a little challenging. I replaced x with 2x minus 4. Now, be careful. I'm going to do the translation first. So I went a translation. There's a couple different ways you can look at this one. Okay, because remember, order does actually make a difference. So if I replaced x with x minus 4, then I would get just 2 raised to the x minus 4. So that'd be a translation to the right, 4. And then if I replaced x, so I did a horizontal shrink by a half, then that would replace x with 2x. So again, the order actually does make a difference here. Next one. It looks like it multiplied by 1/5, and then the x became a negative x. So that would be a vertical shrink by a 1/5, and then a reflection, and since they replaced x, reflection on the y-axis. Last one here is the negative out in front, so that would be a reflection on the x-axis. And then they replaced x with x plus 6, so that would be a translation to the left, 6. Now, we're going to do the same thing with logarithmic functions. So everything we just did before was which is why they brought that up again. It's ultimately the previous slide. Everything's now a logarithmic function, but how you do things are exactly the same. Graphing is a little bit more complicated, but here we go. I went from the log of x to the log negative 1/4 x. So describe the transformation. Well, that is the replacing x. So that is a reflection on the y-axis, and it is a horizontal stretch by 4. All right, so now let's get into the graph. So if I have y equals log x, remember it's base 10. All logarithms are based 10, if not, so 10 to the y equals x. So if I did a XY chart for that one, what if I put 1 in for y? I'd get 10. What if I put 0 in for y? Remember, always put it in for the exponent. It'll make your life way easier. 0 in for y, or negative 1 in for y. So if I graph this, 10, 1, and then 1/10. And so this is it doesn't cross the x-axis, probably a poor picture. I'm going to try it again. It doesn't touch or cross the x-axis or the y-axis. It goes along the y-axis. Next. All right, so if I was going to graph this, this would be log. I'm just going to write it out. Y equals log negative 1/4 x. So 10 to the y equals negative 1/4 x. Well, that's a little bit more complicated. I would go ahead and solve it for x then. So I would multiply then by negative 4. So negative 4 times 10 to the y equals x. So if I'm going to do an xy chart for this, if I put 1 in for y, I would end up getting negative 40. So that number doesn't help me out too much. What if I put negative 1 in for y? Well, now I get 1/10, which is negative 0.4. 0 in for y, I get negative 4. So the graph of this one, 0, negative 4. Negative 0.4, negative 1. And then negative 41 is like way over here. So it goes like this. So notice that it's been stretched 4 times as long. So this one was at 10, 1, and this is at negative 40. And the reason it's negative is because it's also a reflection on the y-axis. So that point is way over here on the graph. So 1/3 raised to the y equals x. And I'm sure they were supposed to also describe it, so let's do that first. Notice there's 3 out in front and they replaced x. We're talking about a vertical stretch by 3 and a translation to the right 2. All right, so I'm going to do the original one. So if I put numbers in for y, negative 1 gets me 3, 0, 1, 1, 1/3. So graphing those, 3, negative 1, 1, 0, and then 1/3, 1. So it goes along the y-axis. Now, if I want to do a vertical stretch by 3, so this would be just rewriting this, okay? And this gets a little bit more complicated. Y is equal to 3 log base 1/3 x minus 2. I really need to divide by 3 before I do the spiral technique. So I have 1/3 raised to the y over 3 equals x minus 2. So 1/3 y over 3 plus 2. So if I did an xy chart for this, I'd probably want to use increments. So if I put in, let's say 0, that wouldn't be too bad. That'd be 1 plus 2 would be 0 for y. I get 3 for x. 3 for y. So that would be 2 1/3. Negative 3 for y. That would be 5. So picking a different color, 3, 0. 5. 1, 2, 3. And then what I have here, 2/3, 3. Last one, and again, this will be on your test and quiz. Let the graph of g be a reflection on the x-axis followed by a translation 2 units to the left of y equals 3 to the x. Write the rule for g. So the original equation is 3 raised to the x power. So if I want to do a reflection on the x-axis, I would multiply this by negative 1. So if I times that by negative 1, I get negative 3 raised to the x. If I do 2 units to the left, I'm going to replace x with x plus 2. So now negative 3 raised to the x plus 2 equals my g function. So again, the rules that you've learned previously are still going to apply. Let g be the translation 1 unit down, followed by a vertical stretch by a factor of 5. So the original is log 1/6 raised to the x. If I want to do a translation 1 unit down, I'm just going to subtract 1 to the entire function. If I want to do a vertical stretch by 5, I'm going to multiply this whole function by 5. So I have to multiply the logarithm and the number. I can't tell you how many of you still do not do the number when doing a vertical stretch or shrink. Your homework assignment tonight is out of the book. I only want you to graph a couple of these. Again, the graphs are not the biggest portion of this. It's more about being able to do the transformation correctly. So again, there's a section in there that's all, so please check your Google Classroom for some of the answers for the all questions. And if you have any questions, make sure you talk to your teacher, and good luck.